Retrieval augmented generation, or RAG systems in production, are built on semantic similarity, finding texts that mathematically feel close to the query. While this works for short contexts, it often breaks down when you scale to long, complex documents. Today, we're going to look at why that flat, mathematical approach fails, and how moving to a structured, vectorless architecture solves these SRE challenges. 3 critical failures of vector RAG, semantic similarity. Let's focus on the top half of the diagram, the blue section outlining the core vector RAG failures. Column 1, lost in the middle, chunking flaw. Failure 1 is known as the lost in the middle problem, or the chunking flaw. Traditional RAG, by design, breaks documents into fixed-size chunks, completely shattering the document context. Look at this visualization. You have large, fragmented documents. Key context in section A, like a critical hypothesis, is now isolated from related context in section C, like a conclusion. A single query may retrieve section A, but miss section C entirely. This isolation leads to an incomplete synthesis, a classic RAG failure where the AI has some of the facts, but none of the big picture. Column 2, hallucinations from disconnected chunks. Failure 2 is direct hallucinations caused by disconnected chunks. This is an SRE nightmare. Look at what happens here. We retrieve disparate blocks of text, chunks 1, 2, and 3, perhaps matching common keywords across different nodes. These are mixed up and lack cohesive flow. When the LLM tries to stitch them together, it generates plausible but false information because it is missing the connective tissue, the logical flow between those ideas. The summary at the bottom here is key. The vector DB acts as a flat bucket, not a map. Column 3. No global document awareness, the vibe problem. Failure 3 is perhaps the most insidious. No global document awareness, or the vibe problem. This visualization illustrates the problem perfectly. We have a fiction story and a technical manual. To a math model looking at semantic vibes, visualized as similar color energy, they can look similar. A user asks a technical query about specific functionality. The vibe match may retrieve content from the fiction document instead of the manual. The query's intent is technical, but because the system is prioritized on similarity math rather than conceptual logic, it gets completely off track.
The 3 PageIndex solutions, structural reasoning. Let's shift to the green bottom half of the diagram, PageIndex solutions. This is vectorless RAG, a retrieval architecture built on document navigation. 1. Global context and multi-hop navigation. Solution 1. We establish global context. PageIndex restores context by building a hierarchical TOC, table of contents tree. The structure seen here, root, nodes, subnodes. This structure acts as a true map. Because this hierarchy is preserved, the system can perform logical multi-hop navigation. If a user query requires context from node 1 and node 3 together, the AI sees that a logical link exists and can navigate between them conceptually, solving the fragment isolation issue. Column 2, precise extraction and verifiable citations. Solution 2, precise extraction and verifiable citations. Instead of retrieving fuzzy chunks, PageIndex retrieves the raw, correct text sections based on its node navigation. Look at the flow. The query points directly to node X in the PageIndex index. Because we are retrieving specific, structured raw sections, we eliminate chunk-induced ambiguity. And most critically for SRE verification, we get a traceable source citation. Every single generated detail can be mapped directly back to its original structural node, cited node X. This makes hallucinations verifiable and solvable. Column 3, logical paths and transparent reasoning. Finally, we solve the vibe problem by visualizing the visible chain of thought. Compare the fiction and technical manual examples again. In PageIndex, we construct a conceptual map overlaid on the documents. The technical query doesn't look at semantic similarity. It traces a logical path through the manual structure. The final summary at the right says it all. LLM analyzed TOC summaries, prioritized technical structure, ignored fiction. The reasoning process becomes observable. There is no hidden vector math. We are prioritizing intent and structure over similarity. Summary and conclusion. If you are responsible for the reliability and safety of a RAG application, you must solve these 3 failures.